We now come to our tech showcase, and this month it is Capture6, an American clean tech company founded in 2021. Now, Capture6 is at the forefront of affordable and scalable carbon capture technology. Their mission revolves around integrating direct air capture with electrochemical recovery of resources from desalination brines. They have a unique approach which addresses climate change whilst also producing valuable byproducts such as clean water, calcium carbonate for concrete, and lithium salts for lithium-ion batteries. Now, to hear more, here is Dr. Leo Park, Vice President of Strategic Development at Capture6. Now, Leo also has a role on the UN climate change as a climate policy expert, and he's got a role as an adjunct professor at Inha University, teaching climate finance, sustainability management, and corporate climate change strategy.
So our journey started about 2 years ago, when we were founded to break this vicious circle, whereby climate change leads to more extreme weather events, and also especially water insecurity by creating a lot of drought across the world, which then called for more desalination and wastewater facilities to be added, which then eventually discharge more like brine into the ocean, which created the ocean acidity issues, and used a lot of the fossil fuel to power those facilities, which then again led to more greenhouse gas emissions and other environmental problems as well. So this is why we were created about 2 years ago to break the vicious circle, and then I'll show you how we are trying to address this. So next slide shows you our theory of a change, whereby again, while we are doing the air capture in a very affordable manner to remove CO2 from the atmosphere, we can also do point source carbon capture using the solvent that we create. And then while we do this, we are trying to also address adaptation as well as mitigation, especially how we can address the water shortage issue, and then by using as much renewable energy possible, and also generating carbon negative byproducts. So basically, our process starts with the brine, which can come from, the wastewater treatment facilities, seawater desalination plants, as well as, the produced water. And then the next step is water treatment, and then followed by electrolysis or electrodialysis, depending on what kind of outputs that we want to produce. And what we need is the sodium hydroxide, which is a very effective ingredient, because once it's exposed to the ambient air, automatically binds with the CO2, and sodium carbonate, which is essentially the carbon mineralization process. And then we'll be using cooling tower air contactors to expedite the air capture process. And then once we have a sodium carbonate, we can then also do point source CCS, and then to capture additional CO2, and then the sodium carbonate will be converted into sodium bicarbonate. Or we can also blend it with the calcium, and then make it calcium carbonate. And all of these can be recycled, or can be supplied to other industry, or even better, stored underground or in the ocean, so that we can permanently sequester, capture CO2. And then while we do this, again, we can recover up to 75% of fresh water from brine reject, and then generate outputs that are carbon negative, and which can be also supplied to other industries. So next slide basically shows you some of the examples how our outputs can be supplied to decarbonize some of the heavy industries, like the steel. So we are very interested in not only removing CO2, but how we can make use of our outputs and byproducts, to help decarbonize the value chains of these heavy industries. Next slide shows you the global pipeline that we have managed to, develop so far, and then of course it's expected to be, grow further. And I will show you some of the three, concrete examples. So this one is a Project Monarch, most advanced project. We are about to break the ground, and that this facility will be up and running in a couple of years. We're starting with a pilot, which it can capture about 70 tons of CO2 per annum, but we are already in discussion with the Palm Water District, which is a project sponsor, to scale this up to 500,000 tons of CO2 capture facility of the next few years. And then we'll be using again tertiary brackish water from Palm Water District's water purification facilities. So just wanted to give you again an example whereby how we can partner with the wastewater treatment facilities. Next example, Project Octopus in South Korea, and this time we'll be partnering with again K-Water, which is the national water agency, and then they are building large seawater desalination plant. So we'll be co-located with this facility, and then even at the pilot scale, we're about to capture about 1,000 tons of CO2 per annum. And we will be doing not only direct capture, but also working with the heavy industrial complex near the the plant site, which emits about 17 million tons of CO2 per annum to the points of CCS. And the last one is a Project Wallaby in Australia, and this time we'll be using the produced water from Pilot Energy's facility, and then again we aim to scale this up to 640,000 carbon capture facility, and then which can also produce about 16.5 million tons of fresh water per year, which is likely to be the largest of a kind outside the US. The next slide shows some of the achievements that we have made. So we were the winner of the Korea's International Water Week's World Water Challenge last year, and then we have received a lot of grants, including 8 million from California Energy Commission, as well as US DOE, New Zealand RRQ, and the Iowa Economic Development Board. And also we've been accepted by prominent climate tech accelerators in the US, including Elemental Accelerator, Third Derivative, Carbon to Value, and Ocean Visions as well. And it's important to monetize the carbon credits we generate, and we've been able to pre-sell some of our credits to entities like Caraset and Cacao Impact, and then have a offtake agreement with the Respira International in the UK as well. So with this, I just wanted to really highlight we definitely need all hands on deck, and then of course we are also trying to address the water issues in parallel. So I look forward to again continuing our conversations. Please feel free to reach out to me anytime, and then again looking forward to having further conversation with all of you. Thank you.
Well, thanks for that, Leo. Now, in addition to atmospheric carbon capture, Capture6 is also actively working in ocean alkalinity enhancement, OAE, something which I've only learnt about recently, but I think is one of the most exciting and impactful areas for addressing the climate crisis. OAE involves dispersing alkaline substances into marine waters to increase their capacity to absorb carbon dioxide, while simultaneously counteracting the harmful effects of ocean acidification. OAE aids the restoration of vital marine ecosystems, such as coral and shellfish habitats, and it enhances the ocean's natural role as a significant carbon sink. Now, OAE is an exciting emerging field in climate technology, which we will definitely be exploring further in future broadcasts.